Hello everyone and welcome to this video on mensuration. In this video we will discuss formulas of surface area and volume of standard three-dimensional shapes which are mentioned over here. We will discuss the formula for flat surface area, we will discuss the formula for curved surface area, and we'll also see what is the total surface area, which will be nothing but the addition of these two, which will give us the total surface area. And also we'll discuss the formula of volume of the three-dimensional shape. So let us begin. Now, before we start, let us first understand what is the difference between flat surface area and curved surface area. If you consider a cuboid, as you can see, it has six faces, one at the front, one at the back, one at the left, and towards the right and left, top and bottom. So it has six surfaces which are completely flat. So you do not have any curved surface in this case. If you consider the shape of a sphere, you will see that it is completely curved. There is no flat area on this sphere. So in case of sphere we will find curved surface area, and in case of cuboid and cube we will only find flat surface area. If you consider the example of a cylinder, it consists of both the flat surface area as well as the curved surface area. Flat surface area will be at the top and at the bottom, and the curved surface area is this entire area will be the curved surface area. Okay, so now you have the basic understanding of what is the difference between flat surface area and curved surface area. Now let us understand what are the units of area and volume. Area is normally expressed in terms of meter square or centimeter square or square, whereas volume is expressed in terms of meter cube, centimeter cube or cube. Now volume is nothing but some area into some length. We'll see how to use this concept in finding out the volume of any shape, which will help you in remembering the formulas quite easily. So let us begin with the first shape, that is cuboid. Now cuboid is basically a three-dimensional shape with certain length. It is like a box. It will have certain breadth, which you can also call as width, and certain height, which is h. So if we find what is the flat surface area, we'll write in the short as FSA. In this case it will be same as the total surface area. So it is nothing but the sum of all the six faces of the cuboid, sum of the area of all the six faces of the cuboid. So if we consider the front face, its area will be nothing but length into height. So this area will be L into H, and on the back side also the area will be same, L into H. Towards the right, if you will see, it will be B into H. On the left also it will be B into H. For this top area, if you see, it will be B into L or L into B. It will have the similar area at the bottom surface also. So the total surface area will be nothing but, if you see, all these terms are occurring in pairs, so we'll write it as 2 times into L into B plus B into H plus H into L. So this is your flat surface area or the total surface area in case of a cuboid. What will be the volume? Now to find the volume, all you have to do is take any one of the area. Say if we take the front area, which is L into H, we'll take L into H and then multiply with the third dimension, that is some length. If we consider this front area, this is the area, and what we are doing is we are multiplying it with the length. So in this case it will be this dimension, which is breadth. So this will be our volume. So take some, while for finding the volume of any surface or any 3D figure, take any one area and multiply it with the third dimension. So if had you considered this top area, this area, which is given by L into B. So L into B into will multiply it with the third dimension, which is the height H, which will give you the volume, which is obviously going to come out the same. Okay, so this is all about the volume and the flat surface area in case of a cuboid. Now we will see two other important formulas related to cuboid. One is the formula for face diagonal and other is for body diagonal. So let us name this figure first. For the bottom surface I am naming them PQ, this H, R, this H will be S, and the top we can name them as A, B, C and D. So what is the formula for face diagonal? Let us first consider that. If I draw a line which will join the vertex P and B on the face, on this face I am drawing a line, so this will represent the face diagonal. So for finding out what is the length of the face diagonal, we'll use the Pythagoras theorem. So this is a right angle triangle, this length is the height and this is the length. So in this case PB will be your face diagonal. So length of the face diagonal PB will be square root of L square plus H square. Similarly, if you want to find the length of the face diagonal QC, it will again use the Pythagoras theorem, which will give us square root of H square plus B square. In similar way, you can find the length of the face diagonal AC. So length of face diagonal AC will be given by, here we have the 90 degree, AC is the hypotenuse, which will be square root of B square plus L square. Square root of B square plus L square. So these are the three face diagonals of a cuboid. Now let us see what is the body diagonal. In a cuboid there are four body diagonals. If I join the point P and C, we'll get one body diagonal. So P to C is one body diagonal. If I join similarly point A and R, we'll get another body diagonal. Similarly Q and D will give the third body diagonal and B and S will give us the fourth body diagonal. So let us find the length of this body diagonal PC. Same will be the length of all the other three body diagonals. So for this we'll first join the point P and R as well. Now notice the point P and R is on the same plane, which is at the bottom plane, and CR is perpendicular to PR. So we'll get a right angle triangle PCR. In this triangle CR is H. What is the length PR? PR will be nothing but your face diagonal. For this face diagonal, what is the length? It will be same as the length for AC. So this is B square plus L square. Okay. So here we have square root of B square plus L square. So we will apply the Pythagoras theorem in this triangle PCR. We will get the length of PC. So length of body diagonal PC will be CR square, which will be X square H square plus PR square, which will be B square plus L square. Square and square root will cancel out. B square plus L square and this whole thing under root. So if we just arrange this thing, we'll get length of PC will be equal to L square plus B square plus H square. This is nothing but your length of body diagonal. So in this way you can easily remember all these formulas. Let us now move ahead to our next figure, which is cube. Now cube is a special case of a cuboid with all the three dimensions equal in length. So let us say if this length is A, so this width or the breadth will also be A, and the height will also be A. So in this case also we have 6 surface, so the total surface area will be same as the flat surface area, which will be nothing but 6 times area of one of the faces. In this case each of these face is a square, so area of a square is given by A square, which will be 6 into A square. You can substitute all these values here. L will be equal to B will be equal to H. All these dimensions will be equal. If you substitute these values, you will get A square plus A square plus A square, which will be 3A square. 3A square into 2 will give you 6A square, which is the same answer that we are arriving at. Similarly, the volume of a cube will be given by, take any one of the area, say let's say the front area, anyway all the areas are same, so A square into the third dimension, which will be the width in this case, which is also A, so we will get A cube. So if we substitute L equal to B equal to H in the volume equation for cuboid, we will get A cube, which is the same. So likewise, if you want to find the length of face diagonal, let's say name it P, Q, R, S, then this will be A, B, C and D. So if you want to find the length of face diagonal AB or PB, we can use the similar procedure that we have used for cuboid, and we can arrive at our answer. So in this case it is a square, so length of face diagonal will be nothing but square root 2 times A. You can substitute the values in this equation. L equal to H, which will be A square plus A square, which will give us square root of 2A square. So A square will come out and we'll get root 2A. On the similar lines, we can get the length of body diagonal, which will be length of body diagonal, say PC. We can use the similar procedure, or we can simply substitute L equal to B equal to H in the above equation for cuboid, which will give us root 3 times A. So these are the equations for total surface area, volume, length of face diagonal and length of body diagonal in case of a cube. Let us now move ahead and consider cylinder. In cylinder, as I had previously explained to you, there are two types of surface areas: the flat surface area and the curved surface area. So flat surface area will be the top face and the bottom face. Okay, so on the top we have a circle, and at the bottom also we have a circle. So if let's say H is the height of this cylinder and R is the radius of this cylinder, so the flat surface area will be nothing but area of this circle 2 times, because at the top also we have a circle and at the bottom also we have a circle. So 2 times area of this circle, which will be pi r square. And in case of curved surface area, all you have to do is take the perimeter of the base and multiply it with the height. This will give us the curved surface area. So perimeter of the base will be same as perimeter of the circle, which is given by 2 pi r. Let me first write it as perimeter of base into height h. So perimeter of base in this case is 2 pi r into height h. So the total surface area in case of a cylinder will be sum of this flat surface area plus the curved surface area, which will give us 2 pi r square plus 2 pi r into h. So if we take 2 pi r common, you can write this formula as 2 pi r into r plus h. You can remember this direct formula, or you can arrive at the formula by observing the figure. Okay, so it will be easier if you understand how to arrive at this formula. It will be easier for you to understand it, for you to remember these formulas. Now let us see what is the volume of a cylinder. So for volume, as I have explained in cuboid also, take any one of the area and multiply it with the third dimension. In this case, it will be easier for us to consider the area of circle. So area of the circle will be given by pi r square, and we will simply multiply it with the third dimension, which in this case will be height of the cylinder. So the volume will be nothing but pi r square into h. So if you understand the logic how to arrive at the volume formula, you can easily remember it. Let us now move ahead to our next figure, which is prism. Now what is a prism? First of all, understand that in a prism we have any polygon at the two bases. Say this is the bottom base and this is the front base. So we can have any type of a polygon. In this case we have a triangle, we can have a rectangle as well, rectangular prism. It will look somewhat like this. So we can have a rectangular prism also. We can have a hexagonal prism also, which will look somewhat like this. So depending upon what is the shape of the base, we can define different types of prism. This is a triangular prism, this is a rectangular prism, this is a hexagonal prism. Let us now understand how to calculate the surface areas of the prism. We'll consider a triangular prism for our understanding. Let this be the length of the prism L, and let this be an equilateral triangle of side, let's say A. So in this case also there is no curved surface area, there is only flat surface area, which will also be a total surface area. All you have to do is take the sum of all the surface areas. So there are two triangles and three rectangular surfaces. This is one rectangular surface on this side. Then on the back side also we'll have another rectangular surface, and this bottom surface, it is also a rectangular surface. So dimension of these rectangular surfaces, this is the length and this is the second dimension, which you can say is the height for the rectangle. So area of this rectangular surface will be L into A. There are three such areas of a rectangular shape, so we'll have 3L into A. This will be the area of rectangular shape. For the triangular shape, the area of equilateral triangle is given by root 3 by 4 into square of the side, so which is A square. So the total surface area in this case of a triangular prism will be area of the rectangle, which is 3 times L into A, plus area of the triangular portion, which is root 3 by 4 A square, and we'll have to multiply this thing by 2 because we have one area at the front and another area at the bottom. You can cancel this out and simplify it further. The basic idea is you have to know what is the area of the polygon. If you know the area of the polygon, you can easily arrive at the total surface area of the prism. Similarly, volume. For volume, we will take any one of the area and multiply it with the third dimension. So volume will be given by area of this triangle, which is root 3 by 4 A square, into length or the third dimension, which is L. So this is nothing but your volume of a prism. I hope you are able to understand this concept. Let us now move ahead. Pyramid. Pyramid is similar to the prism, except that in a prism we have both the ends as some area. In pyramid, all the edges of the base, this is the base. If we name them, it will be P, Q, R, S. These are the edges of the base. All these edges converge into a single point, which is called the apex. This is the apex of the pyramid. Whereas in case of a prism, we have a similar area on the other end as well. As you can see, we have a triangular face here and a triangular face at the bottom also. But in this case, all these points of the bases converge into a single apex. So this is called a pyramid. If you drop a perpendicular from the apex to the base, let's say so, this will represent the vertical height of the prism, which we will call it as h. And if we measure the slant length, this will be different than the vertical height. It will be slightly more than the vertical height. Let us call this as the slant length L. Okay. For our calculation, we will consider this base as a rectangle, which will having some dimension, let's say x and y. This is the base of the pyramid. You can have different bases as well. You can have a square pyramid, you can have a hexagonal pyramid. The base will be hexagon. In that case, all you have to do is remember what is the area of the base. For our calculation, we will consider this as a rectangular pyramid. Let us now calculate what is the total surface area of this pyramid. So total surface area in this case will consist of the area of the base plus the area of the slant surface, which we will call it as slant surface area. Slant surface area. So area of the base will, in case of a rectangular pyramid, will be length into breadth, x into y. For the slant surface area, the formula is half into perimeter of the base multiplied by the slant height. We are not going into the derivation of this slant surface area, we are directly using the formula. So the total surface area will be area of the base, which is x into y, plus half into perimeter of the base. So perimeter of a rectangle is given by 2 times x plus y into the slant height. So slant height is nothing but L. Okay, so in this way you can calculate the total surface area of a rectangular prism. Had this been a square prism, all you will have to do is substitute the area of base as the area of square, which let's say it will be x square, and for the perimeter formula we will have to use the perimeter of the square, which will be 4 times x. So the base can take any shape, but if you remember this formula, you can easily arrive at your answer. So what will be the volume formula? Now, volume of a pyramid, the formula is 1 by 3 into area of the base into the vertical height h. Remember, in total surface area we are using the slant height L. In the volume formula we are using the vertical height h. Again, we are not going into the derivation part, we are directly using the final result. So the area of base in our case is that of a rectangle, which is x into y into the height h. So this is the formula for volume of the pyramid. Again, the base can take any shape, all you will have to do is remember the area of base. Okay, let us now move ahead to our next concept, which is frustum of a pyramid. Now what is a frustum of a pyramid? First of all, let us understand. If you cut this pyramid at say any point along its length, we will get this type of a shape. So the top part will be separated and the bottom part will be separated. This bottom part is known as the frustum. Frustum of a pyramid. Okay, so now we will calculate the total surface area and the volume of a frustum of a pyramid. So let us again draw a perpendicular from the top surface to the bottom surface, which we will call it as vertical height h, and the slant length of the frustum of a pyramid will represent it by L. And then again we have a rectangular base having length x and breadth y. So let us see what is the formula for total surface area. So total surface area in case of frustum of a pyramid will consist of the area of the two bases, area of base 1 plus area of base 2 plus the slant surface area. So area of base, if let us call this as x1 y1 and this is x2 y2. So area of base 1 will be, in case of a rectangle, it is length into breadth, which is x1 into y1. For area of base 2 we will have x2 into y2. Now for slant surface area, the formula is directly half into perimeter of base 1 plus perimeter of base 2 into the slant length, So the area of base will remain the same, x1 y1 plus x2 y2 plus half perimeter of the base. So perimeter of the base, since we have a rectangle, it will be 2 times x1 y1 plus 2 times x2 y2 into the slant length, which is L in our case. So this will be the total surface area. Again, you don't have to remember this formula, just remember this concept. Let me give you some tips how to find the area of a hexagon. If it is a regular hexagon of side A, let's say side A, and let us join all the vertex. Okay, so this is a regular hexagon. All the sides are of equal length. So for finding the area of this regular hexagon, it consists of 6 equilateral triangles of side A. This will also be A, this will also be A. I have explained this concept in detail in our video on geometry. You can watch that also. So this consists of 6 equilateral triangles. Area of an equilateral triangle is given by root 3 by 4 A square. So this will be the area of the hexagon. For perimeter of the hexagon, it will be 6 times A. A plus A plus A, it will be 6 times A. So this is how you can find the perimeter and the base, perimeter and the area of the hexagon. So if you remember this formula, and if you know how to find the area of base and perimeter of the base, you can easily arrive at your answer for total surface area. And let us see how do we find the volume of the first one. So volume will be given by, again, it will be 1/3 into area of base 1 plus area of base 2 plus square root of area of base 1 plus area of base 2 into the vertical height h. If you notice the similarity in the two formulas, volume of the pyramid was 1/3 of some area into vertical height h. This is also 1/3 of some area into vertical height h. The only difference is we have two areas in this case, the top area and the bottom area. So there is a derivation behind this. We are not going into the derivation, we are directly using the result. It will be, so the volume will be given by 1/3 of area of base 1 plus area of base 2 plus square root of area of base 1 plus area of, it will be, sorry, a multiplication here, area of base 1 into area of base 2, and this whole thing will be multiplied by vertical height h. There is a similarity in the formula for total surface area as well, or the slant surface area rather. As you can see, it is half into perimeter into slant height L. Here also it is half into some perimeter into slant length L. So in this way you can try to remember the structure of the formula, and by depending upon what is the shape of the base, you can apply the area of the base formula and perimeter of the base formula to arrive at your answer. For this case, the volume will be given by, since we have a rectangular pyramid, the area of base 1 is x1 into y1 plus x2 into y2 plus square root of x1 y1 into x2 y2, and this whole thing will be multiplied by h. So this is your formula for volume of a rectangular pyramid, and this is your standard formula for volume. Okay, Let us now move ahead to our next figure, which is cone. Now cone, if you see the similarity between cone and pyramid, it is nothing but a pyramid with a circular base. So the formulas will remain unchanged. If we draw a perpendicular from the apex to the base of the pyramid, to the base of the cone, this will be the vertical height h. Let r be the radius of the base, which is circular, and the slant length L. This will be the slant length L. Okay. So the total surface area now will be sum of curved surface area plus the flat surface area. Okay. The flat surface area will be nothing but the area of the circle, which will be pi r square, and the curved surface area, the formula will be half into area of base into slant length L. Similar formula for curved surface area. Same formula that we have used in case of pyramid also. Half into So let us see how do we calculate the total surface area in case of a cone. So total surface area will be sum of flat surface area and the curved surface area. So flat surface area will be nothing but area of the base, which is circular in nature. This will be pi r square plus the curved surface area. So the formula for curved surface area that we have used in case of pyramid also, it was half into perimeter of base into the slant length L into slant length. So this will be half into perimeter of base, which will be 2 pi r. The perimeter of the circle is 2 pi r into the slant length, which is L. So this is L. This 2 and 2 will cancel out, and from this we can take pi r common from both the sides. So pi r will be taken as common. We will have r plus L. So this is the formula for total surface area in case of a cone. Again, you can directly remember this formula, or you can use the logic to arrive at the answer. Now let us see what will be the formula for volume of a cone. It will be 1/3 of area of the base into the vertical height h. Into vertical height h. Please notice the similarity in the formula for cone and formula for pyramid. In pyramid also, we have taken 1/3 of area of base into vertical height h. In case of frustum also, 1/3 of area into vertical height. In case of cone also, it will be 1/3 of area, which will be area of base into vertical height h. So in case of for cone, area of base is pi r square and vertical height is h, which we can write it as pi r square h upon 3. So this will be the volume of a cone. Just like in case of a pyramid, we had a frustum of a pyramid. In case of a cone also, we will have a frustum of a cone. Okay. So if we cut this cone at some point along the length, we'll get this kind of a shape. So this is nothing but your frustum. The lower part is called as frustum. Okay. We'll focus on the lower part. So again, if we draw a perpendicular from the top surface to the bottom surface, this will be called as the vertical height h. This will be your slant length of the frustum, and let us keep r as the radius of r1 as the radius of the base 1 and r2 as the radius of base 2. So again, the total surface area, it will be sum of flat surface area plus the curved surface area. So the flat surface area will be now 2, one at the top or sorry, one at the bottom and the other at the top. So both are circular in nature. It will be pi into r1 square plus pi into r2 square. And then we have the formula for curved surface area. Curved surface area is given by half into perimeter of base 1 plus perimeter of base 2 into slant length. This is the same formula that we have used for frustum of pyramid. Okay, so this, if we apply for cone, it will be half into perimeter of base 1, which will be pi into r1 plus pi into r2 into slant length L. So you can take something common, you can take pi common throughout, pi into r1 square plus r2 square plus half into r1 plus r2 into slant length L. So this will be your formula for total surface area in case of frustum of a cone. Again, you don't need to actually remember this formula. You just understand the concept, remember just this formula, and you can easily solve your questions based on, and then you can easily solve your questions. You don't really need to arrive at this formula also. Let us now see what is the formula for volume of the frustum. So the volume will be given by same formula, 1/3 of area of base 1 plus area of base 2 into the vertical height h. So this will be 1/3 of pi r1 square plus pi r2 square into vertical height h. I hope now by this time you have understand what is the logic behind this formula. Okay, let us now move ahead to our next shape, which is sphere. Now sphere is a solid body. The example of a sphere will be cricket ball. It is also spherical in nature. Okay, so let r be the radius of the sphere. Let us see what is the formula for total surface area in case of a sphere. So in sphere we do not have any flat surface area, we have only curved surface area. So the curved surface area itself will be the total surface area. The formula for this is 4 pi r square. We are not getting into the derivation part, just remember this formula. It is very simple and an easy one. Likewise, the formula for volume of the sphere will be 4/3 of pi r cube. Okay, these are, I think, two of the most easiest formula that you can remember. Let us now move ahead to our next surface, which is next shape, which is hemisphere. So what is hemisphere? If you cut this sphere at some point, you will get a hemisphere. In this hemisphere, we'll have two types of areas, the curved surface area and the flat surface area. Flat surface area will be at the top. So the total surface area in case of a hemisphere will be given by sum of curved surface area and flat surface area. Curved surface area will be half of the hemisphere. In case of hemisphere, the curved surface area will be half of the curved surface area of sphere, which is half of 4 pi r square, which will come out to be 2 pi r square, plus flat surface area. Now flat surface area will represent a circle having same radius as that of the hemisphere. Let's call it as r. So this will be pi r square. If you add 2 pi r square plus pi r square, it will give us 3 pi r square. For volume will straight away become half of what it was for sphere. For sphere it was 4 by 3 pi r cube. So in case of hemisphere it will become 2 by 3 pi r cube. So this is the formula for volume, and this is the formula for total surface area. I hope now you are able to understand how to arrive at the formula for total surface area for volume in case of various three-dimensional figures. In the next video we will solve some problems based on these formulas, so please remember these formulas. We have provided a PDF file for this, the link of which is given below. You can download that PDF file and learn the formula from them before you come for the next lecture. Okay, thank you.